The beginning of the 21st century has witnessed an extraordinary display of natural environmental disasters. An earthquake off the coast of Indonesia in 2004 caused a devastating tsunami, killing 300,000 people.
It was one of the worst natural disasters the world has ever seen.
A similar event off the coast of Japan in March of 2011 caused serious loss of life and a nuclear emergency.
Today there was another fire at Japan's troubled Fukushima plant.
The explosion in Reactor 2 may have damaged the container vessel protecting the nuclear core.
There is now widespread screening for radiation levels.
In January 2010, more than 100,000 people died when an earthquake hit Port-au-Prince in Haiti. While Christchurch, New Zealand, was devastated by an earthquake in September 2010 that led to aftershocks that caused extensive damage and loss of life in February 2011.
Tonight, world interrupted. Warnings that went unheeded.
In 2010, the eruption of Mount Eyjafjallajökull in Iceland spewed out an enormous ash cloud, disrupting air travel and costing the airlines a combined $270 million a day. In Australia in 2009, bushfires swept through the countryside close to the city of Melbourne, claiming 173 lives.
Our worst fears were met.
The development of new forecasting capabilities is crucial to understanding why these tragic events occur and to encourage ways of preventing or minimising the impact of events influenced by human activity. The International Union of Geodesy and Geophysics, or IUGG, works to understand natural hazards better and so to reduce the tragic effects of disasters. The IUGG encourages collaborative research and information exchange between scientists from 69 countries to create a better understanding of our atmosphere, ocean, biosphere, cryosphere, and solid Earth. IUGG scientists supply valuable research to societies and governments, such as providing the tools with which to discover mineral resources, preserve the environment, understand the effect of human civilization on our planet, and predict and plan for natural disasters such as floods, landslides, hurricanes, tsunamis, and avalanches. Water shortage is one of the major problems around the world. Climate change is expected to have a significant effect on the timing of snowmelt, with serious implications for water use and management. Hydrologists measure the movement, distribution and quality of water globally, assessing water resources and making predictions about the future behaviour of water flow and water quality. Cryospheric scientists play a significant role in understanding the relationships between snow, ice, the atmosphere and climate on a global scale. Scientists for the first time recently drilled a hole into the lower section of the Earth's crust, providing important clues on how ocean crust forms and how the Earth has evolved. Geodesists' measurements of the surface of the Earth are increasing our knowledge of the changes to our planet's shape and its gravity, its rotation and to its sea level. Using balloons, satellites and sounding rockets, aeronomers study the upper region of the atmosphere, including the corresponding regions of the atmospheres of other planets. Disturbances of the upper atmosphere, known as space weather, can disrupt signals and communications in the Arctic and Antarctic. Space weather is monitored by observations of the Sun and careful measurements of the Earth's magnetic field. Meteorology and atmospheric science help us better understand weather forecasting, contributing to our understanding of climate change and risk of bushfires, drought, flood and extreme weather events.
There's one thing about Mother Nature: when she gives you a kick in the guts, she gives you a kick in the guts.
"70% of the Earth's surface is covered with water, with 50% of all life found in the ocean. About a quarter of carbon dioxide produced by human activity, such as burning fossil fuel, is absorbed by the oceans. Seismologists continually sense and record the Earth's motion and analyse global warnings. The prediction of the timing, location and magnitude of earthquakes has not yet been perfected. However, more general forecasts are routinely used to estimate a seismic hazard and probable event.
Yeah, just doing what it's meant to do.
Geochemists study the chemical composition, rocks and soil of the Earth and other planets, while volcanologists work to better predict eruptions, collecting ash, pumice, rock and lava samples and measuring tremors and surface deformation, which signal underground magma movement. IUGG works with the International Union of Geological Sciences to run the International Lithosphere Program, a major research program that studies the crust of the Earth. IUGG also works with the International Council for Science, or ICSU, to promote Earth system science-related ICSU programs. And IUGG scientists actively participate in major new programs of ICSU, such as the World Data System and the Integrated Research on Disaster Risk. To mitigate natural disasters, the efforts of natural and social scientists, engineers, industry, policymakers and media need to be combined. IUGG leads a major outreach project on extreme natural hazards and societal implications. IUGG places particular emphasis on the scientific problems of economically less developed countries by sponsoring activities relevant to their scientific needs. Every 4 years, thousands of scientists meet at the IUGG General Assembly to reflect on the urgent need to improve communication with policymakers and the public, to increase knowledge of predictability and reduce the impact of extreme natural hazards. IUGG aims to enable the discovery and responsible use of natural resources, to promote sustainable management of the environment, while satisfying our curiosity about the wonder which is our planet Earth.